see. Okay, I set it to record today, so we'll be good, and let us just do one problem to recall how we can utilize these permutations and when. So for example, if I take a look at the problem number 44 exercise, just as a refresher, that says 20 movies you saw last or this year. And from these 20 movies, they ask you to name best 3. So the question is, how many possibilities are there? So we'll do 43 after that, of course. So how many possibilities? And since you're saying which one is the first, next second, the next third, that means that you assign them positions, those movies. So you do permutations. And out of 20 movies, you can select any 3 and put them in any possible order. And to do this, I will use the favorite formula. So I go to functions, remember? Permutations is the lowest left corner of this set of possible functions. So I go back to main, enter 20, comma 3 in the parentheses, and get the answer. It's 6,840 possibilities. So this is my answer. I used calculator and found those permutations. One more exercise, number 43, that wants us to look at the radio show with 7 songs, and total is 13. So in exercise number 43, they actually have 13 songs, and they want to choose 7 out of those. And the keyword is arrange them. So they don't just select 7, they arrange them in order. So how many ways out of 13 you can select 3, 4, and well, let's still do it. I'm almost done. So it looks like we're going to be doing the same exact permutation story. So we get this permutations from 13 to choose 7. So the good thing is, I hope you start to notice that the problems are very, very similar, right? They go under exact same pattern, but this pattern is something one needs to, well, think about. You don't just choose those 7 songs, but you also arrange them. You order those. That's the key part. The reason it is a key part is because the next section that is called combinations is actually talking about selecting but not ordering those elements. So what does that mean? Well, when you select, let's say, people in class, 5 people from class, and they don't really order, they don't say you need to order them one way or another, just have this group of people to go someplace for a conference or whatever else. So there are no positions, no order will be here. So let me try to show you how this is going to be different with the previous situation. And looks like what they do is they give you a very interesting explanation here down below when they talk about a formula for combinations. Formula for combinations. It looks like what they did, they considered the process of selecting various letters, right? So they say they have 4 letters, and they start to produce different words out of these 4 letters. So what they do is they select 3-letter words. I know that most of them are not possible. One say, what kind of word is ABD? There is no such a word. Well, yes, but we arrange. So the question is not how many actual words, but how many various rearrangements you can produce on these selected letters. And what they noticed was that selecting letters A, B, C, they can have possible 6 rearrangements with them. Why is that? Well, in the first position, you can use any of these 3 letters. You can put either A or B or C. Then on the next position, you have 2 choices. So you can put the BC or switch them and get CB. So the total will be 6. And that's what we can see here. So 6 possible ways to permute those 3 letters. And it doesn't matter if you selected ABC or you selected AB with a D or AC with a D or BC with a D. What does that mean? Well, you could take first 3 letters. If you look at this, A, B, C, and a D. So you may not take D, right? And that's how you get ABC. Or you may not take C, so you get ABD. Or you may not take letter B. You see that, how it goes now? So you may also skip B. Or like in the last case, you may skip A. So there are 4 different possibilities to do the selections of letters. And looks like that's what's called number of combinations, from 4 to choose 3 elements. So you can either take first 3, so you don't take the last, or you may skip the one before last, or you may skip second, or you may skip first. So these are 4 possible ways not to select one of these letters, which means that to select other 3. So the combinations is number of choices that you have without arrangement. In other words, they say, if you have so many arrangements with this ABC, you don't really care for those arrangements. All you care about is that you just selected first 3 letters and no D, and so forth for the last ones. So when you don't care about ordering your selected letters, you go with the number of combinations. And of course, there's also a formula here in the calculator among these functions, the next one next to the combinations. You can see this next to the permutations. You can see this number of combinations, right? So when you go with this, no ordering, but just selecting, it's going to be combinations. And just as we did before, if I go with the 4, 3, 4, 3, I do see that the answer is 4, just like we intuitively saw this already. So when you need to order your elements that you select, you go with permutations. If you don't need to order, well, then you go with combinations, just like it happens here in the first example on that little page. So you can check out this, how many ways to select DVDs. So that's part A here that says how many ways you select 6 DVDs from list of 200. And the answer is you take combinations out of 200 to choose 6. The reason you use these combinations is because they don't tell you that you order those. You just select them, put them in a bag, and keep, right? So they say you can choose any 6 DVDs for free. So you say, all right, so I just take the 6. So who cares which one you selected as the first, which one you selected as the second? You just selected yourself to 6 those DVDs, and that's all you need. And of course, for the calculator, let me get this here. So I'm gonna go to functions. Now we select combinations. Please double check how you can find these on your calculator. And then 6 chosen out of 200 gives you a big number, right? What kind of number is this? 10 to the power of 10. So you need to move your decimal 10 places. 2, 3, 4, 5, 6, 7, 8, and 2 more. So the answer actually is going to look like 824 086 263, right? And a couple of zeros at the end. So it is going to be a huge number of selections. It's like 82 billion, right? 82 billion possibilities. Wow, that's a lot of possibilities. Well, no wonder, because total is 200. So out of 200, not out of 20 or out of 13, you start with 200. So you have quite a few selections to make. So let us get used to this idea of combinations. I guess this is pretty much all this section is talking about. So I'm going to move to the exercises and practice to do some of the problems with combinations. Please notice there are not too many of them here. So I can try some, and I hope we'll all enjoy those. So we take a look at, say, exercise number 2. That talks about 50 people that purchase raffle tickets. And they say 3 winning tickets selected at random. The first price is 1,000, second is 500, and third is just 100. So the question is, how many different ways the prizes be awarded? So the question is, order important? Would this make a difference to you if you get a first prize or a third prize? And the answer is yes. Looks like I get $1,000 or only $100. So order is important. This means the problem deals with permutations. It's not a combinational exercise. So out of 50, we choose 3. And we don't really just select those 3 and give them, each of them, a prize, a hot dog or something. No, first one will get 1 prize, second is the other prize. So if you reorder them, see the key idea, order. Because if you rearrange, if you reorder those people, you will get a different result, right? So it is definitely not combinations. Order is for permutations. And once you figure that out, you just put 50 comma 3 in the parentheses, and this is your answer right here, 117,600. This is our result. So it looks like we have section that now mixes combinations with permutations. So let's try one more. That be like problem number 4 here. I'll let you try odd numbered if you want for homework. I'll do exercise 4 that talks about raffle tickets. So it looks like they start with 50 of those nice little raffle tickets, and 3 winning tickets selected at random. Each prize is $500. Well, out of 50, you select 3, just like in the previous. But since each prize is the same, notice there is no order. It makes no difference to order them because they are all equal. They're all $500. I say, Alex, how do I know that I have to order? Maybe they ordered them. Well, if they don't tell you, it means they don't care. It means there is no order. In the previous exercise, they said there's a first prize, there is a third prize, there is a second prize. So they give you more information. So once they talk about it, it means there is an order. If they don't talk about it, they say each prize is the same, doesn't matter. Combinations, no order is important. And of course, the answer will not be the same because first was dealing with permutations. Now we get combinations, which is going to be definitely way smaller because you don't just arrange. You select, but you do not arrange. So from 50, we choose 3, and we see that it's just 19,000. So notice the previous was way, way larger, right? So if you don't arrange your elements, you get much less possibilities. Okay, so we've got another one here, and looks like they have lots of little exercises that want you to deal with this combination formula. So let me try one, like exercise number 20. Can I divide this to one by another? Let me write it down so I can enter it in a calculator. This is a pure calculator exercise. I just want to be careful when you enter this in your own calculator. So let me just do one for you here. Try one like here. So we go with functions, right? Combinations, 10, comma 3. And then I divide this. And I go back to functions again and get more combinations, right? So I go back to main, 6, comma 4, just like that. And notice we got a nice answer. It's 8, just like that. So these are pure calculator exercises. So you can just enter this and get the answers right away. I think those are nice problems. How about if I try to do one from the practice plus? When I say, Alex, you don't seem to do many practice plus exercises. Well, let me do one, like let's say exercise 30. So you will see these are pretty much same exercises. I just don't ask you to do them because I think it's plenty if you just do practice, but let's do one just to see. So they have 4 people committee selected from 11 persons total. So out of 11, you select 4. So it looks like they don't really tell you anything about the order in them, right? No order. So we got a combinations, 11, comma 4, just like that. So it looks like it's very, very similar story to what we just saw in the previous group of exercises. And that's nice. So I think this is another nice little section, but one needs to pay attention whether you care about the orderings, right? So let me go to combinations. Once again, looks like it's our new favorite. And then 11, comma 4, right? 11, comma 4. So these problems are pretty nice and compact, much shorter than in that logic portion of story, right? So I got the answer 330. So with this truth tables and everything else, it was much more involved. But here it's much nicer. So I know that people like this section. In fact, this section is something that we also see in statistics class. So if you ever decide to take elementary statistics class, then you will see exactly the same combination, permutations, chapter 11, and then also next chapter 12, which is something we're going to also do here, will be continuation of the story, and it's also a key part of statistics class. Of course, in that statistics class, people do more than just 2 chapters from this book, but I think it's a good flavor. So if you're going to like this chapters, then that'd be statistics would be a good class for you to consider if you ever decide to take any more math classes. In fact, statistics is not called as a math, it's called STA, statistics. So prefix is STA. So anyways, how about if you try one for the little quiz for today? How about problem number 5 for today's quiz? So if you want to find the combinations to choose 5 elements from a group of 6. So please tell me the answer. Please let me know how many possible ways this could be done. So combination question.